Hello everyone, I am Suchita Moril. Welcome you all in the video lecture on the topic mathematical modeling. Mathematical model of physical system. A physical system is a collection of physical objects connected together to serve an object. Some ideal assumptions are necessary for this for the purpose of analysis and synthesis of the system. An idealized physical system is called physical model. And this physical model, whenever we represent by mathematically using appropriate physical laws, that means Newton law of motion and so on, then we call these as mathematical model. And the process of developing a mathematical model is called as mathematical modeling. The control system can be represented with the set of mathematical equations known as mathematical model. The model are useful for analysis and design of control system. Analysis of control system means the finding the output when we know the input and mathematical model. Mathematical models are usually composed of relationship and variables. Relationships can be described by the operators such as algebraic operations, functions, differential operators, and so on. Following mathematical models are mostly used. First, a differential equation model and transfer function model. Uses of this mathematical model. We solve the real life problem and it converts into mathematical model and computing it and find out the final output. It facilitated to handle large scale and complicated problems. In following areas, it is highly useful: climate modeling, aerospace science, space technology, manufacturing and designing, environment and economics, material research, drug design, and so on. Mathematical model. Different mathematical model can be obtained for a given physical system by choosing different variables, different coordinate system, different physical laws, and so on. When the mathematical model of a physical system is solved for various input conditions, the result represents the dynamic response of the system. And this mathematical model of the system is linear if it obeys the principle of superposition and homogeneity. That means if the system x1 of t and x2 of t, which are the inputs, and outputs are y1 of t and y2 of t. If there is linear combination of input x1 of t plus k x2 of t, then we get output as y1 of t plus k y2 of t. These mathematical models of physical system are characterized by differential equations. This is the mathematical modeling cycle. Real life world problem we simplified into working model. It represents mathematically by applying physical laws. Then we convert it into mathematical model, translate in terms of computational model, simulate it, solve it, apply it, coding it, then find out the results and conclusion and interpret the result which are useful for real world problems. This is the cycle of mathematical modeling. Now the mathematical model is linear if the differential coefficient describing it has coefficients which are either constant or functions of independent variable. Now here linear time varying system, this differential equation contain the coefficient, this coefficient of the dx by dt is the independent variable, therefore this is the linear time varying system. Now, linear time invariant system, if the coefficient of this differential equation, that means this derivative term dx by dt is constant value, then we call this as linear time invariant system. The dynamic response is obtained by using the differential mathematical tools, that means Fourier transform, Laplace transform, heat transform, and so on. A physical model of the system can be built as the interconnection of idealized physical elements, and these physical elements obeys the linear laws of constant of proportionality, or first order derivative, or first order integration. There are so many types of mathematical modeling. That means in this mathematical model, we form the differential equation, the mechanical system and electrical system. We can convert this into differential equation, that means mathematical model. Thank you.